Hello guys, welcome to our class, our physics class for today. Today we are going to be looking at motion under gravity. Motion under gravity. Under this we'll also consider equations of motion under gravity. So this is Noble Mind Science Tutors Online and I remain Otto Michael. And for today, as I've always said, please get your writing materials ready so that we can go to our class for today. Please, if you have not subscribed to our channel, please subscribe to the channel. Click on the notification button so that when we upload a new video, YouTube will notify you. Also, give us a like, give us a thumbs up. You can reach us through the WhatsApp number that is showing right on your screen. So please guys, if you are ready, let's go to our class for today. We're looking at motion under gravity. Okay, so motion under gravity. We all know that when an object is projected vertically upward, it will experience a gravitational pull that tend to slow down its motion upward. So the motion of that body is governed by the force of gravity. Alright? So when an object is projected vertically upward, it will experience a negative acceleration because why? The body is moving against the force of gravity. Because the body is moving opposite direction of gravitational force, which is directed downward towards the earth, so it will experience a negative acceleration. Also, when the body gets to the maximum height and it is coming down, the acceleration will now be positive because it is coming down in the same direction as that of the gravitational pull of the earth. So the body will have a positive acceleration. Now these signs are very key because when we look at the equations of motion, we see where these negative and positive signs apply. Okay, so when a body is projected vertically upward, we know that initially the body will move. It will move with a high velocity, but gradually as it is ascending upward, the velocity will begin to decrease, right? Because the body will be experiencing retardation. Why? Due to the force of gravity that is trying to pull the body down. Then at maximum height, the body will stop momentarily and begins to come down. As the body is losing speed, at maximum height, the body will stop momentarily before it will now begin to come down. So as it falls, its speed will gradually increase because of the acceleration due to gravity. So as the body is falling without increasing speed, we see that the body is falling freely, or the body is under free fall. So at this stage, the stone or the body is said to be falling freely under the action of gravity. Right? So the acceleration of gravity due to free fall is equals to the force of gravity, because if the mass of the body is taken to be unit, which is 1, then from the equation of motion, from the equation of force, which is mg, force is equals to mass and acceleration due to gravity. So if mass is equals to 1, then force will be equals to g. So under free fall, right, if a body is falling under free fall, the force of gravity is equals to the acceleration due to gravity. Right, so you need to take note of this, and also know that the value of g varies from place to place on the Earth's surface. It is only mass that is constant, but acceleration due to gravity varies from place to place on the Earth's surface. Right, so this is just a brief introduction to motion under gravity. But I want to look at the equations of motion under gravity. So this is an illustration of an object that is projected vertically upward it gets to the maximum height and begins to come down. Now, if you look at this picture, you see that as the body is going up, acceleration due to gravity is negative, and when it is coming down, acceleration is equals to positive, right? At maximum height, final velocity is equals to 0. Also at maximum height, initial velocity is equals to 0. So when the body is projected initially from ground level, at maximum height, the final velocity will be equals to 0. And when the body starts to come down, the initial velocity of the body will be equals to 0. You need to understand this simple concept so that when you are solving any problem, you will know what to apply. Right, so we'll look at some of the questions that applies to equations of motion under gravity. Remember that when we discuss linear motion, the three equations of motion that applied will also apply in these equations of motion under gravity. The difference is just the acceleration that will change. Just acceleration that will change. A will change to g, then the height, the distance in linear motion will become h. It will become height. Okay, so for acceleration under gravity, these are the equations that applies. Remember that in linear motion, the first equation for linear motion that we had was that v equals to u plus at. This was the first equation of motion we had on linear motion. Then the second equation was s equals to ut plus half at squared. Okay, this was the first one for linear motion. This was the second one. Then the third one for linear motion was v squared is equals to u squared plus 2as plus 2as. This was the third equation of motion that we had when we discussed linear motion. Now for motion under gravity, the a will become g, and then the s will now be h, which is the height. Also, you also take the direction of motion. If the body is going upward, acceleration to gravity is negative, right? Then if it is coming down, acceleration to gravity is positive. So if you know that one now, you can see these equations of motion under gravity. When the body is going upward, the first equation is v is equals to u minus gt, because acceleration to gravity is negative. It is going against the force of gravity. Same thing for the second equation, h. We have replaced s in this equation with h. So h is equals to ut minus half gt squared. And then the third one too, same thing. Then when the body is coming down, the g has become plus. So these are the equations that applies when you are talking about acceleration due to gravity. Depending on the directions, you know the operator to use, either minus or plus, depending on the direction of motion of the body. Okay, so I hope that is clear. If you understand the equations of motion for linear motion, this one is just like a review of those equations, right? So these are basically the equations of motion for acceleration due to gravity. Now we also look at how to calculate the time, and then also how to calculate the maximum height attained. Okay, when a body is undergoing gravitational motion, the time of flight and the maximum height attained. There are equations that from these equations of motion we can derive those equations for time of flight, total time of flight, time to attain maximum height attained, as the case may be, right? So that's what we are going to now. Okay, so this time of flight and maximum height for motion under gravity. as I said before, at maximum height, final velocity is equals to 0. So if you want to find the time to attain maximum height, right? Time to attain maximum height. At maximum height, final velocity is equals to 0. So the initial velocity of projection is u. So we just use that equation from the first equation. The first equation is this. That's the first equation. V is equals to u minus gt. Know the sign. The body is going upwards, right? So that's why g is negative. So since at maximum height, final velocity is equals to 0, right? So your u will be equals to gt, and your t will now be equals to u over g. So that gives you the first equation, or this equation, to find the time to attain maximum height. Now, the time to attain maximum height is equal to the time to come down to the point of projection. So, which means that the total time of flight t will be equals to 2t, 2 small t. Now, we already have this t to be this. So, total time of flight will be 2 times that, which is 2 times u over g. So that gives you total time of flight to be 2u, 2 times initial velocity all over g. Okay, so this is what we have here as second equation here. This is what we have here, right? So that's how we will call this one, right? Okay, then the maximum height of attain, that you can also solve from, if you use the third equation of motion, right, you can find the maximum height attained. The third equation of motion is v squared is equals to u squared minus 2gh max, right? At maximum height, we said that v is equals to 0. So if v is equals to 0, then it means that u squared is equals to 2gh max, 2gh max. So if you divide both sides, you want to make h mass the subject of the formula. So divide both sides by 2g. So divide both sides by 2g, you have 2g is equals to 2gh mass all over 2g. So this will cancel out, so that you have that h mass equals to u squared all over 2g. Okay, so you have u squared over 2g. Alright, so this gives you the maximum height, and that is this equation we have here. So these are the equations to find the time, total time of flight. Know that total time of flight is the time to get to maximum height and also to come down. So when you say total time of flight, time to get to maximum height and time to come down, right? So, and this is the equation for maximum height. So once you know these equations, you can use them to solve any problems related to motion under gravity. Okay, so please take note of this equation. Please take notes, put this note in your notebook. Okay, so we are going to solve some problems now to drive home what we have discussed so far. Okay, so this is a question that we need to look at. A ball thrown vertically upward reaches a maximum height of 50 meters above the level of projection. Calculate 1. Time taken to reach the maximum height. 2. The speed of the throw. Okay, so in this question, you are given first of all, bring out the variable you are giving. You are just giving only the maximum height, which is h. You are giving h to be 50 meters, but you know if within yourself that g is equals to 10 meters per second squared. Okay, so you know h, you know g, then which of the equation are you going to use to calculate the time? Which of the equation are you going to use to calculate the time? Right? So the only equation that will relate the h and g together and then time, which you don't know, together is the second equation. And the second equation is h is equals to ut minus half gt squared. This is the equation, this is the second equation. Now, as I said, at maximum height, u is equals to 0. So, which means that when you substitute all this information into this equation, this one is equals to 0. So we are going to have that 50 is equals to half times 10 times t squared. Okay, so you can work this out. You have 50 is equals to 5 t squared. Divide both sides by 5 so that you have t squared as your subject of formula. Okay, so when you do that division, you are going to have t squared is equals to 10. T squared is equals to 10 and t is square root of 10. T is square root 10. And when you check that out in your calculator, you have t is equals to 3.16 seconds. Okay, so that is the time to reach the maximum height. This is the time to get to the maximum height. Now, when you have gotten this one now, the speed of through, right? Speed of through from the first equation of motion. From the first equation of motion, we had that v is equals to u minus gt. Initial velocity is u is equals to 0. So the speed of through velocity is equals to gt, which is 10 times this time that we had before. 10 times 3, u is equals to 0, so we have 10 times 3.16. Okay, so when you work that out, you have 31.6 meters per seconds. Right, so this will give you the speed of through for this particular question. I hope this one is simple, and this is how to apply the equations of motion for acceleration due to gravity. We are going to solve other problems later on. We'll solve other problems later on. So I hope this one is simple and you are able to relate with this question. Okay, so we'll go straight to your test page. So please just do these questions. A palm fruit dropped to the ground from the top of a tree 45 meters tall. Right? How long does it take to reach the ground? You know that at the maximum, at the point of falling down, initial velocity is equals to 0. So that's a hint that I've given to you. So from there you can just find your time. There was the total time of flight of an object projected vertically upward. Remember the time of flight, then remember the total time of flight. Is that okay? So with that you can easily get solve this problem easily. So please just try and answer them. Put your answers. You can send your answers to me through the WhatsApp number that is showing on your screen, and then just snap your answers and paste them. I'll look at them and see how you were able to solve them. Right, so thank you so much. This is where we are stopping this class for today. Alright guys, so please, if you have not subscribed to our channel, please subscribe to our channel, give us a like, and click on the notification bell so that when we upload a new video, YouTube will notify you. So give us a thumbs up, and place your comment on the comment section. You can reach us through the number that is showing right on your screen. Okay, so we're going to stop our class on for today. I'll see you in our next class. Thanks.